Hey, what's up, everybody? It's Mr. Fager here. We're going to get going into a new unit on polynomials. If you followed us previously, we've been talking about systems of equations. Well, now we're going to be looking at polynomials, and today, to get us started, really a look at what a polynomial is, as well as some classification and basic simplification. So, let's get started. What is a polynomial? Well, a polynomial is really an expression consisting of many terms. Now, you have to remember what an expression is. An expression can have variables, constants, or can have a mix of variables with constants. It really depends on what we're trying to find. More times than not, when we talk about polynomials, it's either going to be about arranging them or trying to simplify addition or subtraction, as we'll be seeing today. Now, there's something that we need to know about polynomials. There's something called standard form. There is a standard form of polynomials, and really all this means is that the polynomial must be written in alphabetical order with the highest exponent first. Now, there's some one thing I kind of skipped over here that I want to show you. Examples of polynomials can include, but are not limited to, things such as just constants. Like I said, 5 being a constant, -1 is a constant. You could write those. You can also have a number with a variable. That's a variable expression because we have a variable and its coefficient. You could also have something such as probably 5x minus 3, kind of a combination of the two. But we can also have something further, which will be, I don't know, 2x squared plus x plus 1. We're going to start to see these as we get into polynomials. So this is where the part of standard form is, where we must write the polynomial in alphabetical order with the highest exponent first. Now, this is some classification stuff, and it's actually very simple. Watch this. For most of these examples, we're just going to go ahead and do the odd problems, and we will do the even. We'll leave the even problems for you as like a challenge if you feel up for it. Highly encourage you to try them out, though. When we look at something such as 1, and I think I am going to change my color up. Now, the examples here say, write each polynomial in standard form. Remember what standard form is. It's just everything is in alphabetical order with the highest exponent first. So if I look at number 1, for instance, I see 3x plus 1 plus 2x to the squared power, or 2x to the second power, whichever one you want to say. Now, luckily, there's only x. There's no other variables. So we know that x can come in this order. The next thing we have to make sure, if we're going to rewrite this, we have to have the highest exponent first. Hopefully you realize that that 2 is the only exponent, so it's the highest. So that means that this goes first. So 2x squared goes first. Then we have to go down the alphabetical line. So that means next would be 3x, because it doesn't have a coefficient of 2, it just has a coefficient of 1. Not a coefficient, but an exponent. Has an exponent of 1, coefficient of 3. And then last but not least, we put plus 1. And we put the 1 last. We put any constant last because it doesn't have a variable. It doesn't have a letter with it. So think of it like that. Constants always come last because they don't have any letters, period. We want the letters to come first in alphabetical order, then plain old numbers. So we can try that out with number 3. Number 3 here says w to the third power plus 5w to the second power plus 28 minus w. Now remember, again, we want this to be in alphabetical order, and the only letter I see here is w. Now I can already tell you that plus 28 is going to come last. Do you remember why? It's because the letters need to come first. Anything without a letter comes last because it's not alphabetical. It's just numerical. So we know that plus 28 is going to come last. First, we need to know what to start with. Well, I should say we need to know what to start, what needs to come first. And as I look at this, remember that we want the highest exponent to come first. I see an exponent of 3, I see an exponent of 2, and I see an exponent of 1. But remember, whenever we don't see a number there, we see a 1. So if that's the case, 3 is clearly the highest, and since w is the only letter, w to the third is going to come first. Now, if we're continuing this idea, alphabetical and highest exponent next, it's between 5w squared and minus w. Well, you know that 2 is greater than 1, so the next will be 5w squared. That only leaves, last but not least, the minus w. So this polynomial in standard form should be w cubed plus 5w squared minus w plus 28. I know, that's quite a bit to write, isn't it? The easy thing about this is it's just rearranging to have it in a specific order. Now, as we look at number 5 is going to get a little bit more complicated because we see that there are a's and we see that there are b's. Well, that's okay. We'll work through this nonetheless. Let us see. There's 2ab plus a cubed plus 5a squared b squared minus 2b cubed. All right, now here's the thing. Since there's a mix of a's and b's, we always want just a to come first. A alone is alphabetically first. It comes before ab. So if I do this, I'm going to start out with the a cubed. Remember, like I said, it's alphabetical. A comes before anything. So with that gone, we now have a choice. We have to choose between the 2ab and the 5a squared b squared. Now, why are we focusing on these that have a mix of a and b? We focus on the mix of a and b because if you look at 2b cubed, that just has a b. It doesn't have an a. So it always comes after a. Alphabetically, you know this to be true, but mathematically, when we look at this, it's important to realize that when I have a term with ab, I still have the a, and a always comes before b. Now, when I look at this, again, we want the highest exponent to come first. So if that's the case, we're going to put the 5a squared b squared next, because after that will be the 2ab. Remember, the 2ab has exponents of 1 and 1. So those are going to come first the 5a squared b squared first, then the plus 2ab. Last but not least, now that we've gotten rid of everything else, we have the 2b cubed. Try to keep that in mind. If it still has the letter previous to it, such as the 2ab, it still has a and it has the b, so it's going to come before the 2b cubed. Some simple rearrangement, nothing to worry about, nothing too major. Now we need to talk about degrees and classification. Now this is like the official classification here. We need to look at the degree and the number of terms in order to classify each polynomial. This is actually very simple. If we look at 7, I see that I just have the number 6. We want to break this down based on the degree and the number of terms, like I said. So what's the degree of that 6? Remember, the degree in this case only comes with a variable. So there is no variable there. If that's the case, this is kind of like 6x to the 0. There's no variable there, so this is just a constant. Beyond that, I hope you remember that because 6 is just a number. It's not a number with a letter or a variable. It's just a number. Now, how many terms are there? There's just one. It's just 6. So if that's the case, this is called a monomial. Obviously, you've already seen where I'm kind of pulling these off. So degrees go by the numbers on the variables, the exponents. If the degree is 0, it's a constant, so just a number. If there's like 6x, or as we see in number 9, a 7p, it's linear. Now, if the degree were to be 2, or if I had an exponent of 2, it'd be quadratic. 3 would be cubic, and a 4th degree exponent would be quartic. And then additionally, the number of terms, obviously you can kind of figure this out: monomial, binomial, trinomial, and polynomial. I know we've said polynomial quite a bit already, but really polynomial is for 4 or more terms in an expression. So really that's why we get to this classification stuff. As we look at number 9, I want to point this out again. This is 7p. Well, what's the exponent on the p? The exponent is just 1. So in this particular case, this is a linear expression. Right? That's what the exponent on the p tells us. Now, how many terms are there? There's the 7p and the 1, so there's just 2. That makes this what's called a binomial. Just really using this classification to help us fit things together. Now, as you look at 11, a little bit different. notice the exponent that we have on the a. In this case, I see a 3. Now, because of that, the degree is 3. That means that this expression is cubic. All I have to do is look at that number that's on top. Then we have to ask ourselves, how many terms are there? When I look at the number of terms, I see the 4a cubed and I see the minus 8. So there's only 2 terms. That means that this is a binomial. Woo! Try out numbers 8, 10, and 12 if you have the time. It's definitely important that you get this classification down. It's not the most important thing, but it's a fun little freebie that's easy for us to do. Otherwise, I'm going to go ahead and move on. We're going to go to the next page. Now we're actually going to get into some examples of adding and subtracting. This is what today is all about, adding and subtracting polynomials. Now, part of this is actually going to go back to what we kind of talked about with solving systems by elimination. And we'll see that with this subtraction example. Now, we can add or subtract polynomials by simply combining like terms. Addition is the easiest. Here's a key thing that you're going to want to do as we get into adding and subtracting polynomials. Make sure you are well aware of whether or not you are adding or subtracting, because there's going to be a huge difference when you subtract. When we add, we only need to combine terms that are alike. So in this case, if I'm trying to put these in standard form, like I want to, remember that we want to keep track. We want the highest degree to be in front. So in this case, I see that that's x squared. So I want to combine the x squareds. So negative x squared plus 2x squared, that's going to give me a positive 1x squared. After that, I want the next highest degree to go. And in this case, it's just x to the 1. That's the next highest degree. So is there another x to the 1 over here? Yes, there is. I'm going to go ahead and combine these terms. This is going to be 11x minus 5x. 11x minus 5x is still a positive 6x. And then additionally, we're going to have the last term. In this case, that's a positive 13 and a negative 23. 13 minus 23. That's going to be a negative 10. So this is what happens when we add. Subtraction's a little bit different, kind of like I wanted to set up when I referred back to solving by elimination. Now, if we look at this, notice once again the sign out front. This is a minus. It's subtraction. But just like solving by elimination, if we subtract an equation or expression, this negative is going to get distributed. That is so important to remember. We still want to try and write this in standard form, right? We want this to be in alphabetical order, and we want to have the highest exponent first, then the next highest, and so on. So as we look at this, the highest exponent I can see is squared. It's the one with the 2's. So I'm going to go ahead and combine those. Now remember, that minus gets distributed. So I'm going to have 4x squared. I'm going to have the minus 3x squared. Okay? So that's going to give me just x squared. So then we continue on, and we keep on combining like terms. So now I need the next highest degree. In this case, it's going to be 5x to the 1. So I need to find other x's to the 1. In the second expression, that's going to just be 7x. Now that is going to be 5x minus 7x. Again, that minus gets distributed. 5x minus 7x, that's a negative 2x. Kind of want to organize this a little bit differently, just like that. There we go. And then, last but not least, we need to find the last term. Now, as you notice, in the first expression, I just have 4x plus 5x. Or I should say 4x squared plus 5x. In the second expression, I have 7x plus 3x squared plus 1. That means the last term is just going to be a 1, because there's no constant term in the first. But don't forget that minus gets distributed. So this is going to be minus 1. So our answer to this subtraction example is going to be x squared minus 2x minus 1. Okay, we're going to continue on doing the odd examples. So we're going to do 13 through 23, and I'll give you hints to 25 and 26, but those I definitely would love if you tried on your own. So, looking at number 13, find each sum or difference. Those are the directions. So in other words, we have to pay close attention to the operation in the middle. This is just adding. Remember, we want to keep these in standard form as well. So we need to make sure that highest term, highest exponent is at the front. So when I look at this, I see I've got an x and I've got a 4x. The other numbers are just constants, so these are what we need to put together now. So x plus 4x, that's going to give me 5x. And then the other terms are just constants, so I'm going to have 5 and negative 7. 5 and negative 7 is going to give me minus 2. That, believe it or not, is my answer to number 13. And because I can't combine those terms, right? 5x minus 2, I cannot combine. Those are not like terms. If we look at number 15, I've got a bit of a higher exponent degree. Look at this. From the first one, I can see that the highest exponent degree is 3. Same thing in the second one, 3w squared. So w squared is going to have to be the first exponent term. But don't forget, I have to add the coefficients. So 1 plus 3, that's going to give me a 4. So I combine. Oh, I just noticed that I did something wrong. Did you catch it? I'm taking myself for a ride here, ladies and gentlemen. W cubed. The highest degree is w cubed. Do I see that in the second expression? No, I don't. So that means that w cubed is it. Sorry about that. Then if I look for the next highest exponent, the next highest exponent is going to be 2. Well, look at this. I also have a 2 over here. So I'm going to end up combining this negative 2w and this positive 3w squared. So negative 2w squared plus 3w squared, that's actually positive 1w squared. Next highest exponent, we don't see another w. Notice that? We don't have anything else with w, so now we're just down to the constants. In this case, I have a negative 5 and I have a negative 11. Now we need to combine those like terms. So this is going to become negative 5 plus negative 11, or negative 5 minus 11. When you combine those, you're going to get negative 16. That's the answer to number 15. As we look at 17, once again, the idea is the same. I'm going to switch colors up. We want to find, in each expression, the highest exponent that there is. In the first expression, I see that it's 2. In the second expression, I see that it is also 2. This is the highest expression, this is the highest exponent overall. So I need to combine these. I've got the negative p squared and the positive p squared. Actually, that's kind of funny, isn't it? Because negative p squared plus p squared is going to cancel out. That combined is going to give me 0p squared. Now, I think it's important to write this to say, hey, we did combine those, but we're going to simplify this later on. Now, we still need to find the next highest exponent, which in this case, after 2, is going to be 1. Look at that. I actually have a positive 5p, and then I have a negative 4p. Positive 5 minus 4, that's going to give me a plus 1p. Perfect. That's what I was looking for. Now we find the next highest exponent. In this case, it's not. It's just going to be 0, because it's like x to the 0, or p to the 0 in this case. So I'm going to have to combine the constants, 8 and negative 15. 8 and negative 15, that's going to give me a negative 7. Now I just need to simplify this. Remember, the p squared, the 0p squared, is going to go away, and the 1 turns invisible. So my real answer to this is just p minus 7. Don't forget, as we look at 19, 21, and 23, we still want to take into account the sign in between. Remember, for each of these, we're going to be subtracting now. And that means subtraction is distributed. Don't forget that. So now, if I'm looking to do the same thing, I've got x squared and then I've got a 3x squared. Don't forget that this is going to be subtraction, though. So x squared minus 3x squared, that's going to give me a negative 2x squared. Keep on finding the variable with the next highest exponent, which in this case is just going to be 1. So I've got 17x, and then I've got 5x. That's going to be 17x minus 5x. Don't forget. That's still going to give me a positive 12x. Okay. We're starting to get this. We're starting to move. We're going to be moving a little bit quicker. Look at this. Do this one. Combine the like terms. 4c minus 4c. That's going to give me a 0. Then I've got negative 11 minus negative 11, right? Negative 11 minus 11. Sorry, I hope I said that right. Negative 11 minus 11 is going to give me negative 22. So my answer to 21 is just negative 22. A simplistic answer. Then, doing the same stuff that we've done before, we need to find the highest exponent. The highest exponent that I see in the first one is negative v squared. In the second expression, it is also v squared. So we can tell that the highest exponent is 2. All right, so now we need to combine these. Negative v squared minus, because that's what we're doing, we're subtracting v squared. Negative v squared minus v squared, that's a negative 2v squared. All right, now we need to find the next highest exponent. So in this case, 1. So 7v and 8v. That's going to become 7v minus 8v. That's a negative 1v, or in this case, just minus v. And don't forget, last but not least, we have to combine the constants. So we're going to have to take 14 and subtract 15. That's a negative 1. So all of this, in a nutshell, is combining like terms, but making sure that we do it in a specific order. Now, you could combine like terms as they are and just move along each expression, then redo the order later. That's totally fine. Some quick tips, quick hints about 25 and 26, then I'll get out of your ear. As we see, 25, it says find the sum of 8p squared minus 2p plus 15 and 11 minus 2p squared minus 1. This problem is as easy as it gets. Find the sum means plus. So all you're doing is you're adding these two together. The real one is 26. Now when it says subtract 2w squared minus 5w plus 10 from w cubed plus 6w squared minus 2, there's a specific order. It's saying take one thing from another. So when we take from something, we have to take from the start. What this means is I'm going to start with w cubed plus 6w squared minus 2, and then I'm going to subtract the 2w squared minus 5w plus 10. That's how you should set up 26. So hopefully this fills everything in for you and gets us started on polynomials in a pretty good light. Most of this we talked about was mostly classification and understanding how to write standard form. Really the point of it is we want to be able to combine like terms, but now put them in a very specific order. That's all this is. If you have any questions, you know what to do. Otherwise, I will see you next time.